Okay, let's look at number 6. Describe how the genotypes of capital R, and capital R lowercase r result in the same phenotype. Well, each of them has at least one of the dominant allele, the capital R. And so in simple Mendelian inheritance, if the allele capital R is dominant, then capital R, or homozygous dominant, and heterozygous, or capital R lowercase r, would have the same phenotype, because the capital R would be masking the lowercase r, the recessive. It would be overpowering or masking it. Number 7, summarize how polygenic inheritance differs from Mendelian inheritance. So in polygenic inheritance, multiple alleles determine the expression of a trait. But in Mendelian inheritance, only one gene determines the expression of a trait. So some traits are Mendelian, where there's just 2 alleles, and that gene with the 2 alleles determines a particular trait, and one of those alleles is dominant and one of those alleles is recessive. So that's pretty much the basis of Mendelian inheritance, but it's not always that way. Some traits are not like that. And so, in fact, a lot of traits are polygenic. Okay, let's look at number 8. So analyze this pedigree. If the purple square represents a male with the homozygous recessive genotype with little a, what is the mother's genotype? All right, well, let's look at that. So little a. So this guy's little a, and this guy's little a. All right. So remember that this male must have gotten one of these from dad and one of these from mom. So mom has to have given him a little a. However, if the purple represents the recessive phenotype, then this mom must have the dominant genotype, the dominant phenotype, in fact, because she's not colored in purple, she's colored in white. So she's expressing a dominant phenotype. And so she must have a dominant genotype as well. Okay, number 9, predict the possible blood genotypes of a child using the table below. If one parent is type O and the other parent is type A. All right, so looking at that, we don't know if the type A parent is homozygous for that or heterozygous. So let's work out both of them, because it says predict the possible blood genotypes of a child. All right, so if the parent that we do know, we're going to put up here, and the parent that we don't know, we're going to use the homozygous first, and then we'll do the heterozygous. So in a cross like this, in fact, let's fill those in with a different color, because I think it's fun to use your different colors. So let's do blue. So I, A. And so remember that, first of all, you put these two possible alleles on the top, one parent's on the left, and then if they're on the left, you move across and add them to all the cells that are across. So this one just went across. And now I'm going to do this same thing to this one. All right, and then I'm going to take the ones that are on the top and write them down. So I'm going to go down with this one, and now down with this one. Well, it looks like if the parent who has blood type A is homozygous for the trait, that means that all the children are going to be type A blood, because they all will have this dominant gene. Now, if the parent with type A blood is heterozygous for the trait, let's try this. Let's put this one over here. So that's I with a big big I, and little I. And then we've got some more of the little I guys up here. All right, so now we're going to go across with this, capital I-A, capital I-A, and across with this, little I. And then we're going to go down with this one, and down with this one. All right, so you can see that we have that this, if the parent is heterozygous for the trait here, then there's a 50% chance, or this is a 2 to 2 or 1 to 1 ratio, a 50% chance of having a child that has type A blood, and a 50% chance of having a child, I don't know what I just did there. There we go, sorry. 50% chance of having a child with type O blood. All right, and that is what we're going,